Welcome everyone. We're scouting a pinto bean field in eastern North Dakota today. It's mid-August, and most of the summer has been warm and dry, but in the last couple weeks we've had some periodic storms. We're noticing a disease appear in this field. It's called common bacterial blight. The symptoms we're seeing are primarily on the leaves. They're large necrotic lesions, which are dark areas of dead tissue. The lesions are often bordered by a bright chlorotic or yellow halo. Most lesions appear on the leaf margins. If we look closely at the leaves, we also see some small areas that appear water-soaked, or as if a small drop of oil was soaked into the leaf or the pods. These water-soaked spots will expand and become new necrotic lesions. In North Dakota, there are other diseases that can appear in July or August and can be confused with common bacterial blight. Let's look at the four most important ones. The first two are halo blight and bacterial brown spot, which are also caused by bacterial pathogens. Look up to see halo blight on the left and bacterial brown spot on the right. Lesions of halo blight also begin as small water-soaked spots that become necrotic. Although the necrotic lesion centers of halo blight remain very small, they may produce a very large but rather faint chlorotic halo, which is why the disease is called halo blight. Bacterial brown spot lesions appear as small brown spots, where the disease gets its name. These small brown spots commonly have narrow yellow halos. However, these small lesions will coalesce into a collection of many lesions. Lesions become dry, crack, and may fall out of leaves, giving the appearance as if the leaf had been shot by a shotgun. These three bacterial diseases, common blight, halo blight, and brown spot, can all appear in the same fields, although common blight, as its name implies, is the most common of the three in North Dakota. While it's important to know that there are multiple bacterial diseases in dry bean, differentiating them is not normally critical, as the management of these diseases is essentially the same. However, it is critical to differentiate them from fungal diseases, in particular rust and anthracnose. Look up to see bean rust. On the upper surface of the leaf, rust typically appears as small brown pustules with a yellow halo. On the underside of the leaf, you can clearly see those pustules, like little volcanoes, filled with dusty cinnamon brown spores. These spores can be easily rubbed off the leaf. Anthracnose is a less common disease in our region, but a very important one. It typically appears as sunken necrotic lesions on the veins, which is different than the bacterial blights, which typically occur between the veins. Additionally, when you see anthracnose, you won't see any of the water-soaked lesions which are common with the bacterial blights. But let's get back to common blight, the disease in this field. In the next few weeks, the number and severity of these lesions may increase. The lesions on the leaves are likely to dry out, crack, and tear from the leaves. The pod lesions will go from water-soaked spots to dark, sunken lesions that may express a bacterial ooze in humid or wet environments. Look up to see pod lesions and oozing, and notice that the pods often have both larger, mature lesions and new water-soaked spots. Seeds may also be infected, with or without visible lesions. Other bacterial blights and anthracnose will produce pod lesions as well, and it can be difficult to tell them apart. Scouting for these diseases on the leaves in the middle of the season is important for accurate identification. Although we haven't noticed much bacterial blight in the fields until now, bacterial diseases can occur any time, and their cycles are very similar. Each of the pathogens that cause disease survive in either infested residue or an infected seed. An epidemic that starts from infected seed can start very early in the season and can be devastating. If the environmental conditions are favorable, each plant grown from infected seed has the potential to infect those around them, creating numerous hotspots that will lead to a field-wide epidemic. A relatively low number of infected seeds can be devastating. Imagine, if even 1% of your seed is infected, you will have hundreds of plants infected in every acre if the environmental conditions are favorable. This is why planting certified disease-free seed is so critical for managing bacterial blight. However, an epidemic that starts from infected bean residue is a far more common source of infection in our region, although the yield loss is not usually as severe. That residue, and the pathogens that survive on it, can move around from field to field with high winds, wind-driven rain, and even on equipment. While an epidemic can still occur at any time, at least in theory, epidemics beginning from residue typically occur later in the season than a seed-borne epidemic. Additionally, when an epidemic does occur, it tends to be more sporadic and usually starts along the edge of a field. Regardless of how the epidemic starts, from infected residue or infected seed, we typically don't see much disease until we have thunderstorms. High winds, wind-driven rain, and especially hail damage the beans and provide entry points for the bacterial pathogens. Add water, and you have the perfect recipe for infection. Once disease is established, it will continue to spread every time it storms. Although each of the three diseases need the same water and wounding conditions for infection, the optimal temperature for them is slightly different, with temperatures in the 80s being more favorable for common blight and brown spot, and temperatures in the 60s and low 70s favoring halo blight. Management of common bacterial blight begins with certified seed, which is the best tool we have to limit the likelihood of seed-borne epidemics in our fields. Crop rotation is also important, allowing time for infected residue to decompose. If possible, avoid planting beans adjacent to last year's crop, especially if that crop experienced an epidemic. Although no bean variety in our region should be considered fully resistant to common blight, years of advances in breedings are leading to varieties that are less susceptible, and even a couple new ones thought to have intermediate resistance. Research is ongoing and genetic advances are likely to continue, so when you're considering varieties in the future, look for common blight resistance. One of the most common questions I get about bacterial blight is there something I can apply to stop the disease? The answer is tricky. Fungicides work well on fungal diseases like rust, but generally do not work on bacteria. Pathologists at NDSU have evaluated many different products against common blight and have seen some mixed results. We have seen that some copper products and some sanitizers can reduce disease severity, but we've not consistently seen them protect yield. Experiments are ongoing, and we recommend growers stay on top of the latest research results.